All right, you guys, we're going to take a look at multiplying and dividing rational expressions. All right. Chapter 8 is going to be all about this. We're going to start with multiplying and dividing. Tomorrow is going to be adding and subtracting, and we'll get into a little bit of graphing and eventually solving rational equations. All right. So a lot of information. Generally, kind of this first day is pretty the easiest section of the chapter. So I just want to kind of show you this example as we take a look at more, computation related versus more algebraic related. Okay, same concepts are being used here. So when we simplify a fraction, we're looking for the greatest common factor. We're going to take that out and reduce 8/12 to 2/3. That's the eventual goal when we're simplifying fractions, which are also rational expressions. Okay, it's just there's all numbers, there's no variables. All right, we're going to apply that same concept, simplifying fractions, to algebraic expressions. All right, so if you look, we have the top and bottom. We can factor those expressions, thinking back to how we factored expressions in chapter 4. And then we can take out the greatest common factor, which in this case is x minus 1. And we're left with a simplified expression, x minus 3 over x minus 5. All right. And that's kind of what we're going to be going through today as far as things go. All right. So let's just dive right into example 1. All right. So we're trying to simplify this, and then we're going to state some restrictions on the domain. Keep in mind, with our domain, we're looking for any even root radicals. What am I doing? Radicals or variables in denominator. All right. So let's go through just example 1. I probably won't do every single question in the notes, but please keep in mind you can always look at the print notes for the complete version as well. All right. So if I take a look at this very first example, I notice that it looks like the numerator is already factored. Okay. But let's think about how I can factor this expression. So I'm going to change that into two numbers that multiply to -6 that give me a -1y. I'm thinking -3 and +2. All right. So then this expression goes away. All right. At this point, we want to simplify. Okay. And actually, honestly, before you simplify, it's probably easier to look at your domain restrictions, because it's always important as we evaluate any restrictions on our domain, we want to use the original expression. Okay. In this case, I see y minus 3, and y plus 2 in my denominator. So I know that y can't be 0, it can't be 3, and it can't be -2. The reason I do that before is because watch what happens when we simplify. We lose the y's, we lose the y minus 3's, and we're left with 4y plus 4 over y plus 2. Okay. So if you use the final expression to evaluate any restrictions on your domain, you would only have the -2. Y can't be -2, and you miss those other two restrictions. So really important, after you factor your expression, figure out that domain before you simplify, just in case you don't want to miss anything. All right. As far as the next one goes, we'll skip over B, we'll jump right to C. Looks like the denominator's factored. The numerator I do want to factor. And it looks like I can take out A, B, and I'm left with B minus 5. All right. So then we have our fully factored original expression. All right. We want to state any restrictions on my domain. Okay. I know b can't equal plus or minus 5 based on those two restrictions, or based on those two expressions in my denominator. Okay. Now we want to simplify. Oh, man, those are really close to each other, aren't they? Okay. Because at first it looks like we can't cancel anything because nothing's the same. But those two expressions are really close to each other. What if I were to factor out a -1? That would make this negative and that positive. Now, hopefully you notice those are the exact same, just reversed order. We can simplify those out. We wind up with negative AB over 5 plus B as our simplified expression. So that's a little strategy you can use. If you have expressions that look almost the same on the top and bottom, try factoring out a -1 and seeing if that works. All right. So that's simplifying expressions. Now we're going to transition into a little more multiplication and division with rational expressions. All right. First things first, I'm actually going to skip over A and I'm going to jump right into B. All right. Keep in mind, when we divide by fractions, that's the same as multiplying by its reciprocal. All right. So what I'm going to do is I'm going to take 16mt squared divided by 21a to the 4th b cubed. Instead of dividing by a fraction, I'm going to multiply by the reciprocal. Okay. At this stage, you want to keep in mind that you can multiply and simplify in any order. If it helps you to rearrange it, you're welcome to, but it's not necessary. All right. So I'm going to kind of pick and choose. The first thing I see is the 7 and 21. I know 7 over 21 reduces to 1/3. Okay. I know 16 over 24. I can take an 8 out of both of those. That reduces to 2/3. Then we want to go through our variables. Okay. So I see an m on top and an n cubed on the bottom, which means one of those is going to cancel with one of those. All right. Looking at my a's, a squared goes away on the top. It's going to change that to an a squared on the bottom. B squared is going to cancel with two b's down here. I'm going to be left with a b to the first. And it looks like t is only on the top. So I'm going to leave that expression. So I'm going to go through. I have a 2t squared on top. Everything else canceled and simplified. On the bottom, I have a 3 times 3, which is 9. And then I have an a squared. I have a b to the first. And then an m squared. All right. So again, we're just simplifying expressions. Just remember, multiplying and dividing, you can, multiplying, you can flip the order in any way you want. When we are dividing, you'll want to take your second expression, flip, and multiply. Actually, one of the younger kids I tutor is, teacher always calls it the KFC method. You keep the first one, you flip the second, and you change the operation from division to multiplication. The KFC method. Keep, flip, change. Just remember, dividing by a fraction is the same as multiplying by its reciprocal. All right. As we get into a slightly more complex problem on C, all right, the very first thing you'll want to do when you're multiplying and dividing is factor and simplify. Okay. So as we look at this first expression, I can factor out a 4. I'm going to wind up with 4 times 2x minus 5. The next expression in my numerator, 2 factors of 10 that give us 7 are going to be -5 and -2. All right. On the bottom, 2 numbers that multiply to 35 that give me 2 are going to be +7 and -5. This last expression, I can factor out a 4. All right. And then you wind up with x squared minus 4. And that actually can be factored again because it's a difference of cubes in x plus 2 and x minus 2. All right. So keep in mind multiplication. We can switch the order on the top and bottom however we want. Okay, doesn't necessarily matter, but we want to go through and simplify. All right. I notice I have x minus 2's on the top and bottom. I also notice I have x minus 5's on the top and bottom. And I have 4 on the top and bottom. So it looks like the only thing left up top is 2x minus 5. On the bottom, it looks like I have an x plus 7 and an x plus 2. So as you can hopefully see, factoring, if it wasn't your friend before, is going to be a super big friend this chapter. All right. The last thing we're looking at is complex fractions, and these are really, really similar to B. So dividing by fractions is the same as multiplying by its reciprocal. Complex fractions are fractions within fractions. Okay. So I'm actually going to do B. You can look at A in the notes if you'd like. Okay. So we'd like to go through the problem. Oh, sorry. I'm going to factor this piece. So we wind up with x plus y, x minus y. The bottom is a difference of 2 squares. We factored into y plus 7 and y minus 7. The old KFC method, remember, we're dividing by a fraction, so we're going to multiply by the reciprocal. And then we just need to simplify. All right. So kind of taking a peek at these, notice y plus 7's simplify out. Again, we kind of have that situation where 2 factors are really close to each other, but they're not perfect. So what I can do is I can always factor out a -1, change those signs. Now I have a positive y and a negative x, which is exactly what's on the bottom. So I wind up with a -1 x plus y over y minus 7. Yay! Homework's listed on the bottom. If you do have questions, feel free to ask in class via the discussion board. Otherwise, use your friends. Keep in mind, EOE on the homework means every other even, okay? So you're going to be doing multiples of 4, 20, 24, 28, 32. If you want to do all the evens, go for it. If you want to do all the problems, 20 to 32, go for it. All right, we're just trying to shorten things up a little because some of these problems do take a little bit longer, especially if factoring is not your forte. Again, if you have any questions, let me know. Otherwise, enjoy the rest of your day and good luck on the assignment.